So very good morning to students. Today we are going to discuss about the various mine fans, particularly centrifugal fan, forward bladed, and also some fittings of the fans, particularly Avasi and diffusers, and also some images of the various surface installations, fan outlets. Right. My name is Karuna Kumar. Today's subject is mine environmental engineering, which natural ventilation. Uh, Part and also the subtopic is the mine fans. It's on the mechanical part. This is a precast picture. This is surveying going on for purpose of quantity surveying at the mines. This is a lithometer and also this is an extension lithometer. The squeezer. Like after completion of this topic, you would able to describe the construction details of the backward bladed centrifugal fan and functions of each parts and drives. So this is the basically you are able to understand after completion of this topic. So what is a centrifugal fan? It look like as a similar same construction. Instead of water, it will come to the air. The remaining parts will be depending upon the capacity. It can be size or they will be increased. The word centrifugal means they are moving away from the center. That's the main basic idea of the thrown outside from the center. Anything, including air, if revolved, will have a tendency to leave the center. There are two rings in the pillar of a centrifugal fan. In between these two rings are to the blades of the centrifugal fan. The rings are connected to this shaft by means of the spokes. Even in the centrifugal fan, single inlet and a double inlet centrifugal fan, uh, they will be using the uh, depending upon our capacity or pressure requirement. So this is a very completest centrifugal fan installation procedure. The mine site. This is the one type of section. It is another type of section view. So this is the Yabasi. That is the outlets. So this design also depending on the ground gradually changing in the radius of the outlet. This is the spiral casing. Airfoil blades. These are the backward bladed. It's the most popularly using. This is the impeller. So when they're rotating in the clockwise direction, the air is pushed up to the outlets. This is the main mechanism. They suck the through air and push out to the other sides. So this is a fan drift, which is air coming, streamlinated fan inlet, and V rope drive is also there for connecting to the motor to rotating the impellers. So this is the basic structure of the centrifugal fan. Please note it. So here see that here that will be showing the complete procedure of the plan elevation of the Circo fans. This is a common rotator, airlock, side duct. This is also side duct, reversal duct, reversal duct. The fan is spiral case is more of the expanded chimney. So door is depending upon the requirement door can be closed. This is a sectional view of the uh, fan. Backward blade, airfoil blades, rotation, fan wheels or runner. This is the hub inlet, backward airfoil bladed fan runners. Showing here how the fan is rotating in direction also. The wallet of the central fan, centrifugal fan, fixed diffuser vanes, wallet centrifugal fan. Let's say pillar rotation. Parts of centrifugal fan: spiral casing, Havasi, backward blades, doors, air lock, side duct, reversal duct, V rope, drive. These are the basic parts of the centrifugal fan: spiral casing, Havasi, backward blades, doors, airlock, side duct, reversal duct, V rope, drive. Construction details and functions of backward bladed centrifugal fan. The fan wheel is supported on its central shaft. That is the basic rotator rotor. The backward curved blades or vanes are spade shapes. The wheel is placed eccentrically within the spiral casing, fitted with an expanding chimney. The casing and chimney are features of all the type of enclosed centrifugal fan. So see that the fan wheel is supported on its central shaft. The backward curved blades or vanes are spade shaped. The wheel is placed centrically with the spiral casing, fitted with the expanded chimney. The case and chimney are features of all type enclosed in the centrifugal fan. So here we can be observed the these things. This is the airfoil blades in our impeller. This is a rotor. Similarly, the key here you can observe easily. So this is a avasi, that is a expandable outlets. Then construction detail functions of the backward blade centrifugal fan. The purpose of the spiral casing is to prevent re-entry of the discharge air from the outside atmosphere, to act as a collecting and guiding duct for the air. The effect of Evasi or expanding chimney is to reduce the final velocity of the discharge air by providing a passage of increasing cross sectional through the which air must be passed. It is also served to eliminating the turbulence, promote the smooth flow of air, and prevent re-entry of the air from the atmosphere. So, one thing you have to observe is the re-entry. The air can be recirculating to collect other area of that purpose. The Avasi expand chimneys to reduce the final velocity. So the design is also very important for the eliminating the turbulences of it. Some you see there some figures you can observe here. This is a centrifugal impeller. The blade is backward blade, flow path, violet, uh, peripheral. There is a three velocity here you can be observed here. The peripheral velocity is u, and absolute velocity is c, radial velocity is cm, and the velocity of the resistance to the blade tips is the w. These are the basic for the forward bladed. Sorry, the backward bladed. The forward bladed, the design will be different. So this is the Abasi. So this is volatile glazing. This is the most important one. Other one. Same impeller you can see in the image, the original industry usage impeller. The person will stand there for the big machines. You can observe there. See that the impeller dimensions. This is the impeller. So you can see the backward blades inside. So these are a shaft rotor. It is connecting to the motor. So this is the impeller, which is here shown in the. So this is the same. This part is looking like this. And this is the original mine entry level. There is a booster fan, axial flow fan, you can say, air screw fan. And then this is the actual outlets of the uh, major Awasi at the air shaft, return airway shaft. So this is the fan house. Always there is some other checkings regularly going on. There is a water gauge, pressure gauge. If anything dropping, they're maintaining the alternative arrangement is also made. And similarly, the complete network I'm showing here, what is happening in the mine, how is the air is entering and how is the air is going. See this. It's a downcast shaft. The intake air is coming. So there will be for controlling of dissipating unnecessary to other working places. So their doors are established here. Then intake air we see the blue color is showing going this side and come to the ventilating the working place and return to the some regulator is maintained here to flow control and return this side. Similarly, the air another side is also going on intake. Some air is required boost up because of the pressure is not sufficient at the time boosting the air. Sometimes there no need to go this side. You need to cross this one, just like our roads crossing, the crossing. Uh, this will be ventilated, this path, and return exhaust. Again, this entire will be come to back and upcast shaft is a main fan that is called as a centrifugal fan for the return airway. So this is a complete network for the ventilation is going on how in underground mines. So you easily understand the these concepts of the underground mine ventilation system by through this one. Presently, you are looking at seeing the surface area. This fan. This is this fan. So some specifications you see here for centrifugal fan. Diameter 9 meters for particular model. Uh, Axial width 3 meter. Power 1500 HP. Capacity 24,300 meter cube per minute. Water gauge presents 175 mm. Speed 125 RPM. Peripheral speed 60 meter per second. So these are the general specifications for the 24,300 meter cube per minute capacity. One the almost 1500 HP motor we are using to getting this much of an. So this is a very important to how much your volume is required for how much HP motor will be playing, how much pressure is you are expecting, how to RPM, the peripheral speed is how much. So according to that one, the calculations are going on. So what is the fan drives? That means the prime mover, which is the rotating the impeller. That is, here you see this is a impeller. So this for rotating for this shaft is connecting to the motor. So that what is that drives? That's called as a drive. Which drive will be rotating this shaft? So such will be given. I will explain it here. So the two common type of electrical motors used for the drying fans. There is a two common type of electric motor used for driving fans. One is slip ring induction motor, synchronous induction motor. So see that though these functions will be have to be more aware in the while studying the basic electrical engineering subject. You have to thorough it slip ring induction motor and synchronous motor induction motor, so that you can understand how the motors will be functioning, how they're rotating the uh, impeller shaft. The two common type of electrical motors are used driving fans are the slip ring induction motor, the synchronous induction motor. Both the above type motors run at constant speed depending on the frequency of the supply and number of pairs of the poles. So both of the above type motors are run at a constant speed depending on the frequency supply and number of pairs of the poles. So these are the major influencing factors for the prime drivers for the impeller rotation. And fan drivers. A synchronous induction motor runs at one definite speed. A synchronous induction motor runs at one a definite speed, develops a high starting torque, and has a power factor improvement quality. With AC electric supply, synchronous induction motor prefer to large fans. So naturally go to the AC electrical supply synchronous induction motor. Modern centrifugal fans are driven at the speed varies from the 300 to 600 RPM, much higher speed ranging from the 1500 RPM. So these are the major RPM revolutions per minute things. Fan drives. High speed fans should be directly coupled to the motor. High speed fans should be directly coupled to the motor, which runs at same speed. Low speed motors with some form of a reduction gearing is preferable. This may be either totally enclosed helical gearing or V-rope drive, ordinary cotton rope drives or belt drives, depending on that one. You have to connecting to the drive motor to the shaft. V belt drive, V rope drive, or ordinary cotton rope drive. So totally enclosed in a gearing system. So depending upon uh, the conditions available in the mines. V rope or V belt drives are more flexible or for speed variation or less efficient than the gear drives. The efficiency of V rope or V belt drive is about 90 meters, whereas the gear drives have an efficiency of 95%. So V rope or V belt drives are more flexible for speed variation are less efficient than the gear drives. The efficiency of V rope or V belt drives is about 90%, whereas the gear drives have an efficiency of 95%. Then, reason for preferring backward bladed fans over other fans. The reason for preferring backward bladed fans over other fans. The efficiency is greater than the forwarded and radial bladed fans. It has a rising power characteristics. High capacities of air can be supplied. The power characteristics of a backward bladed fan is non-overloading in nature, and thus the fan is more suitable for operating without overloading the motor. The efficiency, the efficiency is greater. The efficiency is greater than the forward and radial bladed. It has raised power characteristics. High capacity of air can be supplied. Uh, the power characteristic of backward blades fan is non-overloading in nature, and thus the fan is more suitable for operating without overloading the motor. So the efficiency is a very essential for greater than the forward and radial blade fans for concern. It has rising power characteristics because in mine situation is different because resistance is very possibilities there. Residence means when moving in the galleries, the supports are there. Uh, Finished diameter of the galleries not for the suitable for that one. So more air will be lost in the galleries itself. Did not reach the end area. So such situations, the efficiency will be fall down. The efficiency is greater than forward and radial blades of fans. It has a rising power characteristics. High capacity of air can be supplied. The power characteristic of a backward bladed fan is non-overloading in nature, and thus the fan is more suitable for operating without overloading the motor. So power characteristic backward blade fan is non-overloading in nature, and thus the fan is more suitable for the operating without overloading the motor. It is necessary means that the diameter of the fan and the rotational speed should be progressively increased from forward to backward bladed fans in order to get a given duty head. So it is necessary means that the diameter of the fan and the rotational speed should be progressively increases from forward to backward bladed fans in order to get given duty head. So reason for performing the backward blade fan over the other fan speeds because of the diameter of the fan and rotational speed of progress increases forward to backward blade for fan and other to get the given duty head. So that is the main reasons to sometimes you are choosing the backward is better than the forward blade is concerned. So what is the demerits of centrifugal fan? Centrifugal fan give not giving the efficiency is concerned. One, running cost is high because establishment things these are there. Speed is less. Where speed is less, centrifugal fan weighing 40 to 60% more than axial flow fan. So that is also very less pressure developed and less quantity of air is supplied. Less pressure is developed and less quantity of air is supplied. That is one thing. Principles of working of air screw fan. The blades are set at an angle about 10 degrees to 15 degrees to the plane of rotation. The blades are set towards the back side for the air screw fan is concerned, um, towards the plane of rotation. When plane of rotation is we can take it as a plane of rotation. You have to put it into the angle is 10 degrees to 15 degrees. That is important. The water gauge developed and quantity of air produced is depending on the speed of the blade tips. Compared to the centrifugal fan, quantity of air is more. Compared to the centrifugal fan, quantity of the air is more. So these are the per air screw fan is concerned. What is the parts of the air screw fan? Generally, rotors and runners are there. Guide wings and fairings are also there. Cylindrical fan casings are there. These are the some parts of the air screw fan is concerned. So rotors are runners. So these are mostly called the rotors. These are made of aluminum, silicon, alloy, or bronze and are mounted on the main driving shaft. Each rotor has 12 aerofoil section blades which can be adjusted about the radial axis to alter the pitch and arranged for individual adjustments. When the fan is not running, variable pitch blade can be used on front part of the rotor, semi-spherical in shape and is streamlined to after minimum resistance to airflow. So these are the basic some rotor is concerned. So guide vanes and fairings. One ring of stationary guide vanes is placed adjust to each other on a runner on its discharge side. Its function is to counteract the outer line motion of the air. It is fixed to the cylindrical casing of the fan as well as the cone shaped stationary fairings covering the shaft. So this is the construction point of view that you can understand. The purpose of the fairing is a streamline the flow of air on the discharge side. Two roller bearings with a balancing device are housed within the fairing. The column support to these bearings is also streaming to the other minimum resistance. This is for overcoming the minimizing the resistance. Such type of structure we are practicing. So cylindrical fan casing. This is a build-up of a cast iron or sheet steel section with a very small clearance between the blades of the rotor and the casing. The other end of this casing forms the avasi of the fan. So other end of casing is so you can we observe there up to what will cover with you can see the figure number come to here. Yes. This is a observed here. You can observe here. Yes, here. So this is actually Avasi fan house. This figure is not clear. Yes, clear. So this is a casing. The Avasi also have the casing up to the not recycling for the other environment. So this casing is a very important. Such thing is showing. The coming images also there, different mine real situations also. Right. So cylindrical fan casings. Fan drives. What is the mean by fan drives? So they already two common type drives are the similarly like induction motors popularly using for they have more advantages. So methods of drives. What is the method of drive? This consists of an electrical motor housed outside this fan casing and drives the main fan shaft by a V-rope drive and flexible coupling. This consists of electrical motor housed outside this fan casing and drives the main fan shaft by V-rope drive and flexible coupling. Method of reversal. By reversing the electrical motor, electric power, the fan can be reversed although the volume is reduced to less than the off and so also is the pressure. By reversing the electrical power, the fan can be reversed although the volume is reduced to less than the off and so also the pressure. So these are another necessity. Some fittings are required. It's necessity for external fittings, the connecting to the input system to connect to the output system. These are two very important. to measure the quantity of the emission output also. The regular you have to measure the how much quantity is coming, how much. So some fittings you are required to the analyzing the also primer thing. So what are that one? You see it. So fitting of the fan, water gauge, manometer, avasi. So see that the three are very most important for the fan fitting is concerned. Avasi is an outlet, but simply you not lose at the exactly the earth opening, but it will be some extent up to 5 meters or 6 meters. They maintain the avasi in a gradual changing of the diameter. Similarly, water gauge is established in the fan inside the meter. The regular to monitoring whether how much mm 720 mm 700 mm pressure developed. Manometer, inclined manometers are using for the purpose of the pressurizing the peripheral velocities and total velocity calculation purpose. We need the manometers also. So these are the fittings are very important for the fan is concerned. So this is water gauge, generally YouTube manometers, popularly using. This is coming into the ventilation survey part. Can be easily understanding the upcoming classes. So water gauge about that one. The atmospheric pressure in an underground mine can be measured by the aneroid barometer. This is very popular barometer to how much pressure will generating. The difference of the pressure between the nearby points is, however, known by a water gauge. The difference of pressure between the nearby points is, however, known by a water gauge, which is essential. An ordinary glass tube, a U-shape connecting water, and having one open end of U-tube record the pressure difference between the 2 points, which is essentially an ordinary glass tube, U-shape connecting water and having one open end of the U-tube record the pressure difference between the 2 points. So this is the basic construction of the water gauge is concerned. Water rises in the leg which is connected to the point of low pressure and fall in the other leg. So there is a two legs are there. You can observe here. One is the one leg is it, another leg is this one, right? So water rise in the leg which is connected to the point low pressure and fall in the other leg. A difference of 1 mm, that is a 1 mm of a water gauge. That is a gradations are there in a left scale and a right scale. The gradations, when the gradations moving, the difference is 1 mm. That is showing the 1 mm. Represent the pressure difference of the 1 mm equal to 1 kg for that is a 1 Pascal. So this is the general simplified understanding for the and the water gauge by seeing if the gradation is rising 1 mm, oh, that means 1 kg per meter square of pressure is developed inside. So 1 kg for nothing but 1 Pascal. Water gauge is placed in the fan drift. Mostly water gauges are placed in the fan drift, not in the outside. It's fan drift. One end connecting to the atmosphere and other end in the fan drift. So this is a two. One is a one lead is going to the atmospheric air. Another so atmospheric pressure is you know the atmosphere generally the standard is atmospheric pressure. So every air have the atmospheric pressure. So such thing very standard is atmosphere is always is there. One end connected to the atmosphere and another end a fan is it is very near to the fan towards the mine. So as per this one, water you can be pressure can be calculated. So this is inclined manometer. Then here I showing that other what are your previous slides as studies that can be explained one second here. So this is a shaft. This is the called as a uh, for connecting to the impeller. Here the motor is there, the belt drive, reversible motor, flexible coupling is the core fares. So air will be coming to this because without resistance the core fare is there and thrown out the avasi. So cylindrical casing, blade, and this is the rotor and streamlined nose. So the simple diagram for the for a avasi explanation purpose. And then avasi. So that is what is the importance of avasi? Uh, it is reduce the final velocity of the discharge air. So that is also very important. It's a, what is avasi? So in for from reduced level to it's gradually coming to the exhausting system. But if that speed is entering to the outside, there will be problem with the atmosphere. So that you have to large diameter is maintained, large area with diameter. Automatically, the velocity will be reduced. So the reduce is the final velocity of the discharge is the main avasi concept. So the figure is showing here. Yes. So this is the actually, but it's gradually increasing the mouth of the avasi. That is a not what page. Next, another one. By providing a passage of by providing a pass it is by providing a passage of gradual increasing cross sectional area through which the discharge air from the ventilator must pass. By providing passage of area gradual increasing area through which the discharge air from the ventilator must pass. The air leaves the blades tips at very high velocity with a large store of kinetic energy. So it very also the air leaves the blade tips at very high velocity with a large store of the kinetic energy. So potential energy to kinetic energy. If it is where the allowed entry into the still atmosphere outside the high velocity, the kinetic energy would be lost. So this is also very and atmosphere outside high velocity cause kinetic energy reducing. So impact will be less. By reducing velocity in the velocity, some of the kinetic energy is converted into pressure energy within the chimney, which results in the improvement of the mechanical efficiency and required water gauge is produced at less power to serve to eliminating the turbulence and promotes the smooth flow of air. To prevent recirculation of air from the atmosphere, the larger the quantity of airflow and lower water gauge required. So that is important. Quantity more and pressure is less. The greater is the possible saving of power due to the effect of the FRC. This is the advantage of FRC. So this is one model of FRC showing here. Please see the image, the Abasi gradual changing. This is the actual diameter, the how it will be changing. And then another model, go through it. This is another model, Abasi. These are established in the mouth of the shaft or the air shaft. Right? And then now the purpose of all what are the water gauge and manometer, what are these fittings concern. The water gauge is used to measure the fan pressure. Manometer is used to measure fan pressure. Avas it deliver the streamline for airflow. So these are the other fittings of them. So now for the with this one, I am going to conclude the the fans, particularly in a backward blade centrifugal fan. I hope so far you are learning during the around 30 to 40 minutes lecture. You got to know particularly centrifugal fan, how it is construction in the mine, particularly impeller blades, and how the shaft will connect into the drives, particularly which type of drives used, uh, induction motor connecting, uh, and also the frame factor of fittings. That means the Avasi manometer to maintaining the uh, pressure continuously, and also some air screw fan details, some images of the various working models you are. These are you are covered in this band files lecture. So I hope you discussed about quad blade centrifugal fan, volatile central fan, parts and construction details of backward blades, centrifugal fan drives, all screws fans, fan drives. I hope you understand the and also enjoyed this class today. So now I giving some quiz questions, which is very important for the examination point of view, particularly in a competitive examination or ESET examinations. These type of questions will be coming to the this is the which one of the following fan has a more number of blades? Forward bladed fan, backward bladed fan, radial bladed fan. All the fans have the same number of blades, which is correct. Please note down once again. Which of the following fan has a more number of blades? Forward bladed fan, backward bladed fan, radial bladed fan. All the fans have the same number of blades. So the logical question. So such type of questions you have to appear examination so that you can able to answer the any type so far thorough in the that things. And coming to the most of the examination point you have seen, uh, this type of questions coming generally coming into the for academic purpose. Describe the construction details of a backward bladed centrifugal fan and explain the functions of each parts. Or draw the sketch and name the parts and explain each function parts of it, and also the advantage over the other forwarded and radial blade, and also give the comprehensive idea how backward blade is dominating to other, and what are the specific advantages than the these can be described the about this one, including the parts, construction parts also. And one more question also I given here that is also similar to that one. So draw the construction details. Here is it described. Sketch, draw the sketch. Two, three, four sketches I have already given here. We practice. You will available in our standard textbooks also. Yes, yes. This is one figure showing here. This is one figure, and another one more is also there. See, I see the in the starting given a neat uh, sketch also. Yes, this is the impeller. This also you can able to explain during that one. This very there is a empirical formula also there. I will give the next coming classes of the how to calculate the pressures. This is also the ETS. This is the best centrifugal fan construction is concerned. So these are the points. Practice your notes and describe and draw the sketch about the centrifugal fan backward bladed. So well, I now concluding this class. I hope that you are enjoyed today class. Thank you very much.